should be a file geopsy.exe. Did you get it? Pallavi, are you able to open? Harushi? File is given to you. It has been shared by Gautam Chaurasia, my TA. Yeah, that file has been given to you. Gautam, did you give those files? In the WhatsApp group. Okay, from the WhatsApp group, just download the signals, the seismograms. Yeah, they are SAC files. So all those are SAC files, okay, with the extension SAC, SAC, Seismic Analysis Code. You will see within the name there it is mentioned north, south, east, west and the vertical component. So have you all downloaded the files? So what about the people at the back? Okay, thereafter you are supposed to go into this tab file and there is an option import signals. Within the file tab there is an option import signal. So you are going to import the waveforms that are in the SAC format. So then thereafter file and then click on it. So it will open up a window. Because I have already done everything set up, so my path is already there. So you will have to select the path and reach to your files, maybe in download or document or whatever where it is. Okay, thereafter you need to select all these three components and then you must open it. So you can see all the three files have been uploaded into the software and thereafter you need to view these files. Just click on the view tab. And within the view tab there is an option graphic. Okay, if I will click on it, then it will again pop up a window and then you need to drag the files one by one into this window in order to see the waveforms. Like this. So what you see, the top one is the vertical component, the middle one is the north-south component and the last one is the east-west component.
So in my case it's showing reverse.
But that is fine. You can drag up and down. But it doesn't make any difference, okay? because the software is identifying the component from its name. So you can see there is SHE, S being the short period. So all these data has been recorded on a short period seismometer, and the manufacturer name is Geotiny. Is it okay? So now you are required to go into the waveform tab. First you are required to filter the data. Okay. So if you remember in the lecture today, we discussed the frequency range within which we should filter the data is 0.5 to 20. 0.5 to 20 hertz.
Filtering is important, sir.
Yes, it is important to basically remove the unwanted signals from the data. So this is within this frequency range we are going to compute our HVSR curve. Okay. So we are going to filter. There is a tab for filtering. So it will open up a window with the name frequency filter. Either you can take 0.5 or 0.1. 0.1 also should work. 0.1 to 20 hertz, and you need to select the frequency domain filter, that is cosine type. You can also try with another type of windows and then compare how the final HVSR curve is looking like. But for the moment we are going for the cosine. Is it okay? Now press OK. So your signal after removal of unwanted energy will look something like this. Okay, thereafter go into the tools, then click on HYV, HYV being HVSR ratio. So now you see there are some options given at the top: time, processing, output, status. Okay, so you need to select so in the processing, when we were talking about in the morning, you have a entirely long signal, then we were dividing it into a number of windows. Okay, and in each of the windows we were doing fast Fourier transform. Okay, so to get the spectrum of vertical and two horizontal components. Okay, so you can take the length of the windows either 20 seconds or 30 seconds. Okay, so this is totally a play thing. Okay, you should play with it and see what is the difference if you are taking 20 or if you are taking 30. Okay, then I am taking 20 for now, and then I am going to select, I am clicking on the select, then you can see on the signals the windows are created. Okay, and there was one part I also discussed about in the morning. You can also remove the unwanted spikes from the signal. Also you can remove anything unwanted, like maybe the slamming of the door might have been recorded, traffic signal that is unwanted, spikes and all. So if you see any spike, then you can remove it by just selecting this particular feature here. Just remove this thing and then click on the signal. Like maybe this is a spike here, so it will be removed. Likewise here is the
Sir, I am seeing like 18 windows. View all stations, number of windows 18.
number of windows.
18, 18.
I think there should be more. I am seeing 94 windows.
Sir, how to remove it?
Yeah, you just need to click on this. It just beside select, there is a down arrow. Right? Just click on it, you will see there is remove option. Just click on it and thereafter go on to the signal. wherever you see any spike, just drag it in the square or rectangular format, and then you should be able to remove those spikes. So here also I can remove it. Okay, so I have removed some of them. So you can see as soon as I am removing it, the number of windows are reducing. So initially I had 94, now I have 86 because I have removed some of the windows, unwanted signal. Okay, now you also need to click on this anti-triggering raw signal. So if you remember in the morning, actually I should have told you this step earlier. Before removing the signal, you need to click on it. It was already clicked, so it worked in my case. So anti-triggering on raw signal. So anti-triggering algorithm, it will start off to remove those short bursts or the spikes or the unwanted energy. Okay, thereafter you can select those spikes. Okay, after you do so, now you can click on start. So you see something like this. Are you getting it, everyone? So this is your HVSR curve. Very simple, easy to use. Okay, so now what do you see in this picture? You see several colored waveforms. So all those colored waveforms are actually HVSR curves associated with each of the windows. Okay, thereafter you took the mean that is being shown in black solid line here. Do you see that? And around which you have this dashed line. These are the standard deviation around this mean. Okay, so why this has been given? Because when you do the fitting while doing the inversion, then fitting may not be as accurate as to fit the data. So even if your fitting is falling within this window, within this variance or the standard deviation, then also you can consider it correct. Okay, but more or less it should follow the pattern. So from this HVSR curve or the mean HVSR curve, what do you see? What interpretation can you make about this particular point of observation? F0, yes, very good. F0. Yeah, so fundamental frequency you can find out, right? So fundamental frequency will be associated with the largest peak of the HVSR curve. Okay, so if I will ask you, if suppose the HVSR curve is sharp, the peak is sharp, or the distinct peak you see, what does it mean? Okay, right now you are seeing like this, right? It can be like this also. That means it's a sharp peak. Are you getting me? Okay, first you do until here. Everyone finish it until here using the data that we gave you. So you just select the 30 minute
Sir, exactly 20 minutes data.
Mm-hmm. Or you can go for windowing. Thereafter, you remove the windows associated from here to there. Okay.
On this window.
So you have already dragged it. So thereafter, did you filter?
No, sir.
Where you filter it? Oh, it's already there. So this is you filtered it. Thereafter, go into the tools, HYV.
I have selected the time, sir.
That is fine.
Here cosine only.
Why it is coming different? Where are the windows? Okay. 20-second window. Okay. And then you can remove some of them. So where is the waveform? Yeah. So just to go here and select everything like this, and it will be removed. They are not removing. Oh, you have already computed everything. Go from the very beginning. Just close it down completely, then
सेटिंग चेंज कराना पड़ेगा, ऑक्सीजन वैल्यू थोड़ा फर्क आ रहा है ना.
setting.
वो रॉ सिग्नल का जो एस टी एल टी होता है ना, शॉर्ट टाइम एवरेजिंग, लॉन्ग टाइम एवरेजिंग, वो मेरे में तो सेट है पहले से, मुझे चेंज कराना पड़ेगा.
But this is looking fine. So you have removed most of the signal. Looks like.
नहीं सर, ये मीन्स दे हैव नॉट चेंज द सेटिंग ना, सो ऑटोमेटिकली 18 विंडोज इज गेटिंग सिलेक्टेड.
Okay. So you have your own data.
नो नो, दिस इज आर डाउन.
Same data.
सेटिंग इज डिफरेंट.
Done. So you have removed many of the windows. You have removed how many windows you have?
इसमें सिलेक्शन होगा.
Kareem? Done? How many windows? Now you got 18 windows. Why you are getting 18?
Sir, I'm not sure, but I think.
Oh,
during
you have
the-
removed many windows actually from this. This is no. Did you remove some windows?
No, sir.
It came like this only?
No, it was all overlapping. So
Then?
I arranged it in that style
How did you arrange it?
by docking it like this. I was just moving the window.
You have 18 windows because you see this is one window, this is second, third, fourth. What about in between?
Sir, I did not
Uh,
click on anywhere.
Oh, it is coming like that only.
It's coming like that. I gave cosine type.
Mhm. Can you please redo it? Just close the entire software. Oh yeah. Now, did you filter it?
Yes, sir.
Okay. Now click on the tools, HYV, and then this is okay. If I want to remove, but the windows are not coming. Why? So this tools option is gone.
Writing So it is automatically computing, sir.
Because when I'm opening again, it is asking me for this.
So this is fine.
Is it all right?
This is this is this you should close. Just drag your signals and but you will not be able to find the fundamental frequency. No, actually, maybe the window selection is wrong. You might have removed too many windows. How many windows you are getting?
83.
Thereafter, you are getting what? This thing. You have done everything what I have done.
Yes.
So mine is coming like this. Just reduce this overlap. Actually, you have computed everything. That is why it is not working. You will have to reload everything to redo it.
Should I do it?
Hmm.
Remove some windows, you can remove some windows. If you want to add some windows, you can add. And again, you can start. This is which changes, sir.
We need to tell that to him, or he's asking why is it 80.
No, no, no.
So anybody can answer me why we are looking at the frequency associated with the largest peak? What is its significance? Yeah, if it matches the resonance frequency, then it won't be a good sign, right? So we will have to make sure that the designs of the building should not match to the fundamental frequency. Okay, the resonance frequency. So in this particular example, if you see here on the slide, there is a peak which is very sharp. It is sharp peak, right? And if suppose there is another HVSR curve which has a flat peak, then what is the difference? So peak, you said already, it is associated with the fundamental frequency, and you don't want to match it with the resonance frequency of the building. Okay, but what else it can tell you about? It can tell you about anything about the thickness, or it is telling you about the contrast, impedance contrast between the soil layers and the basement. Because if you go deeper, as you dig down, first the soil layer comes, thereafter some solid basement will come, hard rock, right? If the area is not very thick in sediments. Okay, so there will be hard rock. So between hard rock and the soil above, the contrast will be largest, right? Even if you look at the soil layers above, the contrast will be there between different soil layers, but the largest will be between the bedrock and the soil layer above, right? So that is basically this peak, which is associated with the largest peak, is representing that particular contrast, the largest contrast between the bedrock and the soil layers. Okay, so using this peak, if you know the average velocities of the soil layers above, then you can possibly find out the thickness of the soil layer, or you can say the depth of the basement, depth of the bedrock you can find out. Okay, otherwise what you will do, if in order to find out the depth of the basement or the bedrock, you will have to dig a borehole. That we don't want to do. Okay, this is the purpose. It is a non-destructive, non-invasive technique, and also cost effective too. So that's why this peak is very important. Okay, if suppose I will consider the soil layers velocity, shear wave velocity on an average, maybe let's suppose 700 meter per second. Okay, let's suppose. And here what you see, the frequency, the fundamental frequency is how much? In this case, what do you see? So first thing you must notice, on the x-axis, what do you have? Log of frequencies, right? Right. So you need to find out the frequency there. Okay. So I think it is around 2 hertz, 1.8 or 2 hertz. Okay, I am just take a whole number, 2 hertz. Okay, 2 hertz is the frequency, fundamental frequency, and I told you the formula. Okay, F naught is equal to Vs upon 4h. Vs is 700 upon 4h, that is equal to 2. So how much is the thickness? Seven point seven, 87 point something. So 87 meter may be the thickness of the soil layers. Okay, if the average velocity, if you consider like 300 or 400, then it will be even lesser.
Yes, you said first was 700.
Yes.
That is yes.
Yeah, 700 I said because in case, let's suppose, if you are talking about the Bengal basin or the area of Ganges basin, then there you have a very thick pile of sediments, okay, in kilometers. So you do not have really a hard rock if you go deeper. Okay, so what the standard says, if you do not find a hard rock, then wherever your shear wave velocity at whatever depth, it comes around 700 meter per second. That you consider it as the depth of the basement.
At 87.6 something to the surface, at this point, ground amplify or whole?
No, at this particular platform, or you can say the basement or bed, that is where the basement is, hard rock is located.
Actually, there is high contrast
That is the highest contrast.
between soft soil and hard.
Yes, very much correct. Okay, but I took too large velocity. Okay, considering we are talking about the deep pile, but generally the average velocity that you have up to 30 meter is around 250 meter per second or something. Okay, so once you take that, then see if you take 250, then what is the value you are getting?
BS you said and FC
F0 is 2.
thirty-one.
31.2 meters. Okay, if I will take this example for which we did the processing, so here you can see our peak is coming at around 1 hertz, right? So if I will take the same 250, then Hmm? 62 meters is the depth of the basement in that area. Okay, but the certain answer you will get after you do the modeling. Okay, this is just the approximate one.
So this is the engineering basement.
The first one was engineering, where you were taking 700. Engineering bedrock.
No, actually, geologically speaking, our basement rock might be something else.
Something?
It might be something different. It may not be.
Yeah, in case of, as I told you, let's suppose you are talking about Bengal Basin. The sediments are too thick over there. Okay, basement is not really present. Okay, or you can say unapproachable. Okay, so in that case, the standard, as per the standard, it says that wherever the shear wave velocity goes to 700 meter per second, that you consider as a engineering bedrock. Okay, now my question is still there. So let's suppose you have this peak. You see, this is the sharp peak, very sharp. Okay, it is not always true that you have a very high contrast, sudden high contrast will be there between the soft soil layers and the bedrock, hard rock, right? It may be possible that the change is gradually happening. Okay, but still the bedrock is there, but the soil layers just above the bedrock are also very hard in comparison to the bedrock, but still lesser harder, but they are still hard. So that means the change is gradually happening. In that case, you will get a flat peak. Okay, in that case you will get a flat peak. Okay, distinct, sharp, peaked, so like this one, and the flat peak, the peak is flat, so it is like that, and sharp is like that. Yes, that is a very good question. Suppose if you will get it more than one peak, then what will be the case? So in this case we are getting actually. Let me show you. Mhm. So let's suppose this is also a peak around 8 hertz. Okay, there is the largest peak, and just beside it below there is another peak. What does it mean? Topography is not flat. Any other answer? Well, try. Very good. Rimpi, you tell me. Yes, Shubhajit, please. Yes, there are two different contrasts. Right? So that is why I just said to the Subhajit, the mathematicians are better geophysicists. So you can see here the two peaks are there, that means two different contrasts might be present, and because the second, so that particular peak will be known as secondary peak. Okay, then that another peak is coming at around 8 hertz, that is higher than the fundamental frequency peak, right? So that means it will be located below the basement or above the basement. Why? Huh? Yeah, you are applying that formula. Yeah, that is also one way. Or you can just simply think about Earth works as low pass filter. Okay, that means low frequencies will basically talk about the deeper depth, and high frequencies will talk about the shallower depth, right?
And sir, is there any possibility that first lower peak will come first and then the higher peak?
That is also possible. That is also possible. It happens. So what does it mean? That is also a very good question. Yes. He is saying, what if the secondary peak is coming earlier in the frequency domain than the fundamental peak? So Gautam, did you see that scenario while you did the processing for your points? The secondary peak was coming earlier.
No, sir, in my case.
It was not like that.
But when he comes like that, we need to refer the systemic guidelines.
Yes.
It has been mentioned there.
So basically he is right. It may happen, but you need to ensure first that the whatever HVSR peak you are getting, it should follow the CSAME guidelines. CSAME guidelines I just showed you in the morning in one slide. I did not went on to explain it, otherwise it would have become so tedious for you. Okay, first I wanted you to make understand these basic things. Okay, but the question is correct. Okay, it may be possible, it may happen. Okay, there is also possibility that it may be coming due to maybe some kind of error in the data. It may also happen. Okay, the processing steps are not.
Yeah, when he's saying secondary peak is coming earlier
Earlier means in frequency domain.
in frequency.
Yes. That means that peak you are seeing, the secondary peak, instead of coming later after the fundamental peak, it is coming earlier.
Then why will it not show here?
Because it is not here.
It's during the data capture.
No, you did not understand the point, I think. He is just asking, like in this case what is happening? This is your fundamental peak and this is your secondary peak. Okay? It may also happen that there is such HVSR curve where the secondary peak is basically coming here before the fundamental. It may also happen. Na? So what could be the possible reasoning behind it?
It can be like a ratio base.
It can be the ratio of.
For example, there is one thing I saw, STA by LTA, or
Hmm.
LTA by STA, that
Mhm.
one. But that one was in relation with some energy.
Hmm.
So that's why I was
We will
asking.
come to that STLTA later.
Sir, it is related with artificial noise also.
Yeah, these all are artificial noise.
It means just like moving train.
It may be possible that you applied the anti-triggering algorithm. It is not correctly applied. You did not remove the spikes associated with some unwanted signals in the data. Okay. Okay. So actually what happens generally, instead of looking at single HVSR, you want to look at the HVSR that is just adjacent to the point. That means if you are not taking only one observation, right? You are taking several observations for your HVSR work. Okay, just beside that point there is another point. Do your HVSR processing steps and then see if you are getting the same thing what you are getting in the previous point. If you are not, then there might be some problem, or there might because the points are very near to each other. Okay, they are very proximal. So the geology will not change much. Okay, until unless there is really something. Okay, because generally we do collect these data like within like there is one point, then within 100 meter we are taking another point. Okay, so for example in the morning I just showed you for the area of Nirsa, we covered a area of around 3 by 3 kilometer. Okay, 81 points were there. Around at a distance of maybe 200 meters we collected our samples. Okay, so you might have also seen those 2D VS profiles where you have seen the topography associated with the basement topography. Okay, so that was also following a trend. It is not like that at one point the basement is 50 meter, at another just adjacent to it the basement was around 100 meter. It is unlikely, right?
That means if suppose from here to 1 kilometer, the material is homogeneous, then from for each point we will get exact peak at particular frequency.
Yes, you should. In theory, you should.
So from that we can define the depth level.
Hmm.
Suppose if frequency changes accordingly.
Then you can make the topography of the basement without even digging a borehole.
And sir, from this figure, whether we can say something about amplitude increase, means just like we
You are saying the site response. So whether it is being amplified or whether it is not being amplified, you tell me, what do you think? Because HVSR ratio is similar to the transfer function. Okay, that is the theory is saying. Okay, it should be similar to the transfer function. And transfer function is what? Transfer function is the ratio of the ground vibrations that you receive at the surface to the ground vibrations at the bedrock, to the vibrations at the bedrock. Okay, that is equal to, as per the theory, H by V ratio. So here the H by V ratio is around coming at the peak at around 3.5. Is it? So that means amplification factor might be around 3 or 3.5. But you need to make sure that you have correctly constructed your HVSR curve following the CSAME guidelines. So do you see like there are several other HVSR curves are also displayed? associated with many windows. There are many outliers also. Okay. So what do you say about that? Gautam, please share other data. So that they can compare. Okay, we have I think 2 more data. 1 more data. Just compute the HVSR curve for that data and see what is that. So the observation point is near to each other. Okay, see what is the difference do you observe. Do you see any difference at all, or there is a difference? So how far the other point is? 300 meter. It's a very simple technique. You can understand. You can go into the field, half an hour data you can take, and then move to other point, other half an hour. Within a day you can basically collect 12-13 point within a day. That should be enough to cover a maybe 1 kilometer long profile, under which you can see how the velocity variations are happening. For a small project, this is a good thing. So now do another data. Did you get the HVSR? Okay. So Mr. Gautam Chaurasia has been working on this software very rigorously and has already submitted a paper on this using around 90 points in the region of Champaran, Raxaul.
Do we need to import the signals in the same way, in the same place here, or like we save this and close and
You can save it first, okay, in .hv format, and also the figure you can save. Thereafter you import the another data.
yeah, it's showing .gp by.
Yeah, that is fine. There should be another format .hv.
It's just showing .gp by.
Gautam, please help her. She want to save the HVSR curve. ये उठाना पड़ता है।
ये बंद हो गया था।
Did you compute?
No sir, due to maybe I am fetching that single file without
Having other component.
means it has the component but the file is merged. That's why I am facing problem. Means the three component is in one file.
No,
Oh,
nothing will happen with that.
Huh?
Nothing
So
will.
it is not from
But maybe the naming convention, because of which the software may not be able to identify which one is east, west, north, south.
it is identifying.
Sir has told me that it was
Import file.
the earth data, right?
Just this one. Okay. Open.
Hmm.
It is three components.
Then, actually, what I have suggested, you can just remove this part until here using the window. Just remove the earthquakes using windows.
HYV. ये उस समय तो हुआ था ना ये?
हुआ था।
Minimize कर. Yeah, this middle one item. Windows it is not creating.
Graphic.
Graphic issue.
और सर यहाँ पे कुछ नहीं आ रहा है।
उससे नहीं कुछ फर्क नहीं पड़ेगा।
कंसोल में
उससे नहीं फर्क पड़ेगा। During 202515 यहाँ चेंज है ना। डेटा कब से है ये?
Oh, go back. Go to the same window. No, go to the same thing.
स्टार्ट है 00 से स्टार्ट हो रहा है।
HYV toolbox.
Yeah, here. Why it is showing hertz? No, this is fine. Start.
Please just wait. Remove this one. Maybe.
Select in Windows, select करना. 0.
Digitizer name sir.
अभी सर कुछ दिन पहले हुआ था। हाँ।
मतलब बना था अच्छे से. अच्छा बन गया था.
बट वो रिमूव नहीं हुआ था, हमने पूरा विंडो लिया था।
ओह.
बाद में रिमूव करने के
रिमूव
बाद
करना नहीं सिखाएगा ना वो।
नहीं उसके बाद वो रिमूव आगे नहीं जा रहा था। जैसे इसका फ्रीक्वेंसी सर आई थिंक 18 हर्ट्ज आ रहा था। 16 अर्थक्वेक का। बट उसके बाद वो रिमूव करने के लिए ट्राई किया, वो नहीं हुआ।
सॉफ्टवेयर
फिर वो डेटा नहीं ले रहा है।
एक बार
दोबारा बंद करके क्लोज एवरीथिंग एंड देन for the second point.
Second file.
Or for that one, how much? For the first one?
फर्स्ट वन सेलेक्ट से बिल्ड किए थे
नहीं कितना, what was the fundamental?
1.09
There is not much difference, right?
ये
So because they are adjacent to each other,
1.18
so it is confirmed that the adjacent peaks are not having much change in the geology.
सर एक क्वेश्चन जैसे ये हमारा जो आ रहा है वैल्यू एच का वैल्यू आ रहा है 80 समथिंग 80 मीटर और फिर ये हमारा जो बिल्डिंग वगैरह है इसको हम कैसे अफेक्ट करेगा ये रेजोनेंस फ्रीक्वेंसी का उसका कौन सा मुझे
Resonance frequency, this is the fundamental frequency.
सॉरी फंडामेंटल फ्रीक्वेंसी और हमारा जो कुछ मटेरियल है मतलब या बिल्डिंग है उसका कुछ रेजोनेंस फ्रीक्वेंसी होगा वो मैच करता है तो फिर कोलैप्स होता है वो कॉन्सेप्ट में उसको हम कैसे मैच करेंगे तो ये हमारा इतना हमारा जो ग्राउंड एम्प्लीफिकेशन हो रहा है वो अराउंड 80 मीटर बिलो हो रहा है सरफेस से
नहीं 80 मीटर बिलो नहीं हो रहा है. Ground amplification तो this is the value,
एच का वैल्यू
amplification.
एच का वैल्यू जो हमारा आ रहा है वो
That is the information that your basement might be lying at 80 meter depth, above which all the soil layers are there, the soft soil layers. Okay, so that is the information you have about the shear wave velocity profile. Okay, how the velocities are varying within that particular depth. Okay, using this curve you can have an intuitive idea what is the depth of the basement. Okay, and using this curve you know what is the fundamental frequency, and this should not be matched with the resonance frequency of the building. That is the only idea. Okay.
सर यहाँ बेसमेंट रूप का मतलब वैसा नहीं है कि कोई हार्ड रूप है बेसमेंट रूप मतलब जहाँ पे कॉन्ट्रास्ट
Hard ही है,
जहाँ पे कॉन्ट्रास्ट है
most of the time hard ही है.
अच्छा मोस्ट ऑफ
नीचे रिसेप्शन पे बोल के आइए, हमने तो बोला हुआ है, ईमेल किया हुआ है.
ज़्यादा नहीं आ रहा है सर 16.81 हर्ट्ज 16.85 हर्ट्ज दिस इज मे बी ड्यू टू हमारा जो ऑब्जर्वेटरी है सर एग्जैक्टली हार्ड रॉक के ऊपर
Okay.
फ्रॉम दैट वी हैव टेकन
हाँ,
पिलर
yeah.
मे बी एक वो रीज़न हो सकता है शायद
That might be the reason. So it is on the hard rock.
यस सर
So you constructed the pillar.
Yes, sir. From I think 15 feet down, we have constructed the building.
Hmm. So why 15 feet? That is the basement.
Sir,
That is the hard rock.
Hard rock, sir.
So that is the basement. So that means you already know the basement.
This one I have done, the second one.
Yes,
F0 is 0.3 something.
that is too less.
And I'm getting 84 millimeters.
Hmm. It should not be too far from what you got for the first thing.
First one was 1.3 something. This one is
हम्म,
बोल दिया
तो
भूल ही गया, मैं उसको भूल गया था
भूल गया
भूल गया था मैं भूल गया लेकर आया
ले
हाँ ले अभी आ रहा है चाय के साथ बिस्किट भी बनाए
बोल रहा
है ना भूल रहा था क्या मैंने कहा बिस्किट
है ईमेल किया हुआ है
टेक 120 सेकंड डेटा, उसके लिए आपको पहले इक्विपमेंट स्टेबलाइज होने के बाद ही डेटा लेना है, अदरवाइज
After maybe 15-20 minutes. After 20 minutes maybe.
आफ्टर 20 मिनट
Maybe because you need to keep yourself away from the instrument also. You need to make sure that the coupling of the instrument should be good with the ground. Okay. So I have one more question. Like if suppose you are getting multiple peaks, like I saw in some of the HVSR curve that you compute. So what does it mean? Instead of having single peak or maybe two peaks, you are having multiple peaks. Okay. The first thing you must remember, we are just having a we are taking, this is just an example. Okay. It may be possible that you are not what you are getting is different from what others are getting. Okay, that may be due to several reasons, but it also can happen for a point you are getting multiple peaks. Okay, in the HVSR curve. So what does it mean?
we have multiple contrasts.
That may be possible because of the complex stratigraphy of the region. Okay, one more question. So like if you why you are dividing the horizontal component by the vertical component? Why not vertical by horizontal?
Because we will not get any changes in vertical component.
Yes, very good.
In horizontal component we will get radiation.
Yes, vertical component is actually in the Nakamura paper. If you just focused upon in the morning, in that paper they proved that the vertical component is the one which is least affected. Okay, what you get at the bedrock, it comes similar as to the surface. Most of the time the horizontal component gets affected the most. There are the least changes. Yes. Are you asking something? Okay. You do it like this. Okay. There is tea outside if someone want to take. Okay, one or two people at a time may go.
Sir, is there any possibility that H/V ratio is less than 1?
Hmm?
Is there any possibility that H/V ratio is less than 1?
Yeah, it is possible. That means the waves are not amplifying, it is de-amplifying. Because it is similar to the site response or the transfer function. Right? So transfer function is what? Ratio of the vibration that you are getting at the surface to the bedrock. Okay. If it is less than 1, that means amplification is less than 1. That means the wave is de-amplifying. Okay, what motion you are getting at the bedrock, it is while getting to the surface, it is not as much as what you had at the bedrock. Right?
Sir, but in that case, this technique is failed.
This so you need to follow Sisame.
Because sir, this is based on my assumption that at the bedrock, the HY ratio comes out to be equal to 1. And
That is true.
when we move above, then
No, but he is not asking about the bedrock. He is asking about the surface.
yes,
He is saying at the surface, the peak amplitude is less than 1. Okay, so that is possible. Not at the bedrock, he is asking. Okay, did you do the second point? Anyone has the knowledge of seismic analysis code? Or maybe Seism? Can you do this? Can you compute this HVSR in Sison? Because the steps are simple. You need to convert into different number of windows. Thereafter, for each window, you need to do FFT. Then you need to unselect some of the windows. Maybe you need to remove some unwanted signals, like in your case you have earthquake. But from the earthquake data also HVSR is computed from in many papers. We also have written couple of papers on that. Actually, they are not stationary. Okay, the mean value of those noise components that we are removing is unstable. They are abruptly changing. Okay, so they will give the bias in the data. So that is why we need to remove.
Maximum frequency of the soil comes within this range of 0.1 to 0.1.
Generally. So what does high amplitude of HYV ratio indicate? High means 5, 6, 7, 8. What does it indicate? Like you asked me if it is less than 1. It also may be possible it is very large. What does it mean? Higher amplification, yes. Higher amplification, because there is too much of a contrast between the soft layer and the harder bedrock. That means the hard bedrock is there, but the soft soil is very soft. So HVSR itself is telling you about many things. Although it's simple, like whenever you are going in the field to install your seismometer for recording earthquake, just take a small short period with you. During that period of maybe 1 day or 2 days, just collect the data over there.
Because sir, while selecting the site, we carried out noise survey.
Yes.
So that noise data is we are taking on the soil itself, not on the platform. So comparatively, we can make the before construction of the site data and after construction of the site.
Before you do, right?
Yes.
After the construction, everything will become concrete. Can we? For computation, you are asking what surface wave is having the higher contribution. That is what you are asking. Love wave or Rayleigh wave. As per the theory, Rayleigh wave is having the largest contribution towards HVSR. Yeah. I am unable to hear you. Actually, there are many waves, Stoneleigh waves, torsional wave. So, arrival time of them, I am not actually sure about it. So, like normal modes also come later on. So, yeah, mathematically, I have seen some papers those who talk about many other kind of waves. Okay, so not much of a research in terms of realistic observations has been done. There is another kind of wave, shear coupled PL wave. Okay, so yep, research is going on.
If mathematically the wave exists, sir, then there may be possibility that in our seismograph it may also exist.
Yes, maybe or may not be. Yes, that's true.
But sir, if we convert this translational motion into rotational motion with phi and theta, so in that case we will obtain that wave.
Yeah, that is what they do mathematically also. Okay, it is possible. Okay, but we need a suitable instrument to record that kind of particle motion. Okay, so as Shubhajit has said, it is quietly correct. Our instruments are not that good enough to record those kind of waves so far. Okay, but in future it may be possible.
मिनट में सर चाय आ रहा है वो
Pallavi, you don't have any question? Everything clear? So now you should, since you understood everything, you should you should obtain 100% marks on the last day. It may also be possible that you don't get any clear peak. Is it possible? Gautam, did you see any scenario where you did not get any clear peak?
Yes, sir. It has been again mentioned in the survey guidance that how to interpret that.
Yeah. So how did you interpret it? I am asking.
I mean,
Maybe sir, it may be due to the medium is homogeneous.
yes, exactly.
Is
Ideally.
what we are considering up to say 50 millimeter depth, yeah. 60.
Yes, that is the reason. There is not much of a variation in the
What's the question? Can you repeat? Sorry.
Question.
अच्छा, if it's flat. मतलब
Sharp.
many lines are there, but sharp peak is not.
there is no peak at all. Clear peak is not there. So now do you think you can do a small project on HVSR? You will see lots of literature, like once you type in HVSR curves on Google, you will see lot of literature. Okay, many people because it's a small project, so I prefer my master students to do it using the ambient noise data, not for the earthquake data.
So we will collect at Pune because there are three dams near to. So near to the.
Cool.
So near to that site we will collect data and we will show you.
So can we take data from you so that we can take it to NCS?
You wanted to do reverse because in we get data from NCS. We don't give data.
We are in the data center. I did not pick my point, like the data that you have, which you have already converted to peaks and everything, so you have done. Just for some sort of literature study work, can I get from you? Because I'm having for a few cities, I'm already having the HVSR plots, but maybe you might have for something that we are not aware of.
Yeah, if we have the data, we can certainly provide it to you.
The process.
Yeah.
So suppose sir, our data is down or up baseline. Suppose it is not exactly matching with the baseline. So here one option is there, remove trend. So
Yeah.
before filtering the data.
Yeah, remove trend and remove mean, that is required to be done before you do anything.
Actually, HVSR peaks for Delhi. So I was
Delhi.
thinking, yeah, for Delhi, I have seen that. I was doing some write-up on that. And I was thinking that if I can have similar case studies, so what all you might have. Like,
For Delhi,
and Delhi, I'm having. The plots are there.
we have Dhanbad area, we have Nirsa area, we have Champaran area, we have. Okay. But if you have Delhi, I think for Delhi region, some publication is already.
All publications are there in Delhi, so it's just for my understanding, I'm making some write-up.
Okay.
Is there any software that suppose give you collect data from number of sources, HVR data? From that we will define velocity model, depth process velocity,
Mm-hmm.
open source software.
Yeah, you can use Denver. Okay, so we will do it tomorrow. Okay. The modeling part we will do it tomorrow.
Sir, is there any process to convert the process data back to the SAC form?
No,
Because
process data is also SAC form.
that will also be SAC.
It can be.
Then I am probably seeing only the images,
Hmm.
not the raw one. When I asked for the raw one, I was said that they get it from there. They are working on it for some other reason.
But you guys have a lot of data.
So we have the software also there on the system.
Mhm.
The thing is that the training purpose we have been sent here is कि सर से सीख के आओ, फिर आके आप data हमें जो फिर हम देंगे ऐसे.
That is okay, I think.
That's it. So I was thinking कि यही से
Or you can download data from maybe Iris. Okay, they have earthquake continuous data also they do provide.
Yes. I recall Utpal sir was saying.
Yes. The strong motion data you can download it from Pasmos, Cosmos, and there are many other websites, USGS,
Sir, are you writing any paper on this present?
many people.
I mean at present, I mean.
Yes.
So can I take down?
Oh, okay. Actually, that's so nice of you that you want to be a part of it. But the contribution to be significant should be significant in order to become co-author or author of the paper. So, like the person who has done all the part, like collection of the data, thereafter processing, now he is writing or writing the paper. So, if I will put you in there, then he will not feel good.
No, it's completely fine. Actually, I'm trying to understand the workflow of the research system. I have never been in formal research environment other than that in Monash.
Uh-huh.
the
So you
thing
can
is,
stay 10 more
my
days.
paper is already in progress, but that is in a different field, so I am not exposed to earthquake field. So that's why I'm trying to get it exposed.
Do a short project with me.
Then I'll leave it.
Or you can do a short project with Professor O.P. Mishra sir.
Sure.
Okay.
He will also talk about the same thing, like maybe he will tell me, sir, say no, sir, so bad.
And no. Actually, he is much more experienced, so he will provide you much better insight into all this. So, how many total stations are there from NCS right now in all over India? 168.
It's there in the report.
Okay, in the report was published when?
Last after Nepal earthquake, sir.
Nepal
25 Nepal earthquake.
2000.
Nepal or Tibet earthquake, 7 point.
Okay, not Tibet, some part of China, right? Yeah, Tibet. Okay,
In that it was mentioned that data from 168 stations.
okay. That's also, but they have a very good network around Delhi.
It's 8 stations.
Hmm.
And NCS is also having tie-up with NGRI and other institutes. So it is complex.
So since it's a national agency, so it must be having tie-up, not even in India but also abroad too.
Sir, I have one question, sir. In morning session, you mentioned about multi-channel surface wave analysis. So by using HVR ratio, whether it is possible to find out exact site for doing the multi-channel surface wave analysis?
Multi-channel, where the?
Multi-channel surface wave analysis to find out the velocity, shear wave velocity. By doing H by V ratio, we will find out the site where we will get the fundamental frequency and maximum amplitude. So that site we will select for multi-channel surface wave analysis. we have exact information about VSRT.
Then in that case you will be basically investing lot of time, because first you will do HVSR, right? Thereafter, once you find the highest peak somewhere, there you will do MASW survey, right? That is what you are doing, saying. But one by one you are going to do the selection of the point, and it will take a lot of time. Aren't you getting me? But you know, like the complementary approach, people do generally do it. For example, like they collect the HVSR data, okay, using which they can find out the contrast, the depth, because HVSR curve do not generally provide a very good estimate of the shear wave velocity. Okay, it is just an average. Okay, average of maybe top 30 meter, 40 meter or whatever. Okay, but in contrast, the MASW method provide a good estimate of the shear wave velocity, because you are going to compute the dispersion curves. Okay, and dispersion curves are basically sensitive towards the shear wave velocity, absolute shear wave velocity. So, using the HVSR curve, you may get an idea at what depth the contrasts are located, and using the MASW and the dispersion curve, you know what is the velocity variation. So if you do them together, then you will be able to better image the structure over there. Okay, so that is what I was talking about in the morning. Like you give one data, you have more models. When you give more data, then you have significantly less number of models. That means you are moving towards the uniqueness of the model, because our earth structure is unique. Not, you cannot say that number of models are representing the same structure. There should be one model. But since the heterogeneity is so much that our data is most of the time is not sufficient to explain that structure. Okay, so that is why you need to have. So that is why in geophysics, many of the times people do integrated approaches. Okay, so integrated means like you are doing seismic survey, someone is doing resistivity survey, another person came doing magnetotelluric survey, and all of them together, then thereafter they are coming up with the best model. Okay, so that is what also can be done. इसको हटा लो।
मेरे पास एक VS30 का प्लॉट है, उससे VS30 कंप्यूट करा सकते हैं ना? बोला भी।
कहाँ देखो? So the girls came from Lucknow. Are you enjoying here? So is this your first visit to ISM? I think 3. Okay. So tomorrow, what we are going to do, we are going to model the HVSR curve. After modeling, you will get something like this. This is the model. Okay. So this will be different for each observation. Okay. This is for a particular observation. So in this particular model, you see the depth is varying from 0 to 30. Okay. So what should be the value of VS30? Because you are required to find out the average shear wave velocity up to 30 meter depth. So when we say average, what does it mean? How would you compute it for this particular model? This is the model, right? Do you agree this is the model? Do you think it is a model of shear wave velocity? Because you can see with depth on the y-axis and on the x-axis you have the shear wave velocities. Okay, you can take a mean model because that is a population of models, because you have run some certain number of iterations. With each iteration you got a model, and all the models are populated here. That is why you see thick lines. Okay, but if you will take just a model which is a mean model of all of them, then you can identify a single model, that is the mean model. Okay, just intuitively you can see or visualize the mean model is basically tracking in just between just in the middle of these populations. Okay, so using that, what should be the VS30 value? So first layer, there are 3 layers, right? First layer is around 3 meter thick. Second layer is around how much thick? Maybe 16 or 17 meter thick. Okay. Third layer is 10 meter thick. For the first layer, what is the velocity? 100 meter per second. Right? For the second layer, what is the velocity? 100 and maybe 30 or 20 meter per second, 30 meter per second. Okay, 130. And for the last layer, it may go maybe around 260 or something, 270. Okay, 270 meter per second. So these are the values of each layer, thickness and the shear wave velocities.
The last one is like the red one.
No, in the middle. Just look in the middle of the yes. Okay, just look in the middle. This is the middle. So this is the middle, right? This thing. Are you getting me? Okay, the mean model you are taking. So what should be the VS30? How would you calculate the VS30 for this thing? 30 for top 30 meter. It is 30 meter total. So what does your mathematics say, Mr. Subhojit? H by V. That is also one way. That is correct. Right. 30 divided by H1 by V1 plus H2 by V2 plus H3 by V3. That is what you are saying. Right? Do you all agree? So just calculate how much it is coming. I am just saying the middle part, whether it is gray, red, blue, green, whatever.
Yeah, but the thing is the legend is showing like a gradient map. So if you look at the gradient map, it gives an impression that the value is ranging, like if I can see correctly, it is ranging from 0.018 to 0.02.
Those are different things. Those are misfit values. Those are different things. Misfit means for each model you computed a synthetic HYV and then compared it with the observed HYV, and whatever the difference you got, the misfit value you got, that is shown here. Okay, that doesn't actually, it is not required here in the computation of VS30.
So we can just imagine that it's a central line to it.
Yeah, actually intuitively you can imagine, but there are more sophisticated approach to find out a average model. Okay, just for the learning purpose we are doing it like that. $140.
140. If we consider h1 is 3 and velocity 100,
Mhm.
h2 17, velocity 120,
Hmm.
h3 10 and velocity 270.
Yeah, that is correct. Second? Okay, yeah. Actually, first and second layer, there is not much difference in the velocities, right? So, yeah, top two layers are dominating. But if you look at the top one, the thickness of that is very low in comparison to other two layers.
Sir, I'm not following how is he taking the layer differentiation, because I would divide the layer like 2-3 times at least. Like the first where there is a break,
Yes.
I will break it there, and then the second time I'll break it here near 20, 10, 12, 15, 16, yeah, almost 16 to 18, somewhere in between I'll break.
Yeah, actually, just take the middle value. 16 and 20, the middle value is 18. Let's take that value.
But why not there, like 4 or 5?
Where is 4?
The top one. Is it the top one? There is a small
Yeah, that we are taking.
getting that one.
Yeah. That is why I said there are 3 layers. तुम्हारा दोस्त कहाँ गया? हैं?
कर रहे हैं सर,
हैं?
वो दोस्त पूछ रहे थे ऐसे ही हुआ सर।
अरे वो कहाँ गया?
वो सकता है।
Yeah, you might have taken the different values for the V. So all in all, you understood the concept, right? How much you got? Sumoji, are you following?
Yes.
Sir, when we do the forward modeling,
Mm-hmm.
we have to first take under consideration the height of the bedrock. Here in this case, suppose if we have to do forward modeling, so there are 3 layers, 1, 2, 3. So what height the bedrock should we take? Like the
These are the soil layers on the top.
yes, soil layers on the
So those are not hard rock.
yes, yes.
Okay. Wherever the highest contrast lies at this depth maybe, that is the bedrock.
So from this picture, can we say about bedrock
Yeah,
or
yeah, that might be at 16, that one.
that last?
Because there you have the largest change in the velocity.
Yes, yes,
Okay, in this model, just take the case of this model. What do you think? Where is the bedrock? नहीं है क्यों
Bedrock का velocity 760 meter and above we can say.
no you took me wrong
I have taken layers at 0 to 4, like 4 by 100 plus 10 by 150 plus 15 by 280.
Mhm.
And then 30 like this. I'll see how much is that.
how much you are getting
Final value I'll calculate.
okay
But I'm taking this.
this is fine
Three values should be 30 now.
Yeah.
No, 16, 10, 25, 5 should be there.
Oh,
वो
अच्छा.
thickness
The
भी दिखाना चाहिए ना.
हाँ तो I've taken here ना 4 and
हाँ.
then this.
sum of the thickness
Okay. 50 plus 10, 25 plus 29. अच्छा. इसको 5 मिलेगा.
Do we have to collaborate with HVSR?
yeah around 16 meter yes but there the contrast is more largest yeah that is the largest contrast
But sir, it may also possible that the contrast between two soil is also more.
yeah that is
rather
possible
than, bedrock.
that is possible
So for that.
you can actually what is happening here we are measuring up to the 30 meter
Yes, sir.
you can also take generally when we show our model we generally show it for the deeper depth
Okay.
okay then we will get to know how deep is the bedrock
Means at bedrock we will get more contrast.
if there is they can penetrate in case of an earthquake. I have seen papers using surface wave to find the upper mental velocity also. Long period waves can penetrate deeper. Long period, larger wavelength.
Even if you do MSWR also.
No, that will not. That will not. That also can do, but you will have to have a very long array of receivers. There has the thing has been done before, a very long array in maybe hundreds of kilometers. Because that is how the people could find out the first impression of the moho.
Sir, in introduction seismology by Stein, it was given that surface wave velocity depth is 0.4 of wavelength, whereas low wave velocity depth is 0.25 of that
I'm
wavelength.
getting 176.47.
I got it. Yes. What?
I got 176.
Yeah, that is good.
Penetration depth is like this, sir, for surface wave, and for low wave it is 0.25 of the wavelength.
This may be the resolution that you are talking about. This is the velocity, what?
This is the penetration depth, sir.
Ah, okay. Yeah, that is actually, wavelength is what? It goes like this from the surface like this.
Yes, sir.
Okay, so like approximately somewhere here where the maximum amplitude lies. So lambda by 4 is this, or maybe for the Rayleigh wave it is 0.4 lambda. Okay, that is the maximum depth of the penetration. A sensitivity kernel, just to look at.
That's why, sir, in one of the book I read that for getting VS30 value, we have to select the length of that your study is 90 meter. So suppose the array length is 90 meter, and if we multiply by
Yeah, lambda by.
so, more 36 meter, we will get exact value.
Yeah, that is true. That is actually the sensitivity
Okay.
or resolution depth. Done. Are you guys staying far away from here?
Yes, yes, sir.
Where?
So we don't exactly know the location.
But how much time it takes?
So half an hour.
Half an hour. Do you know the name of the area? Wow. So is it your relative who is?
Yes, sir.
Okay.